In this video, we are going to cover something called lists. So this is going to build on what we learned last time, where we created arrays, which were collections of a fixed type, and arrays were a fixed size. Lists are going to be a dynamic size. So they're still a fixed type, and they're still going to default to being zero-based when we think about pulling things from a list. But the list can grow and shrink dynamically as we need it to. So that sounds pretty nice, right? Well, at that point, you might think, well, I'm never going to use an array. I'm just going to stick with lists. Those are dynamic, so those will be easier for me to use going forward. And that's kind of true in Intro to Programming, but there is a trade-off here. So arrays, because they are fixed, that makes it easier to optimize them, make them more efficient. And that means that the dynamic nature, we're kind of trading off some of that efficiency for flexibility in terms of our coding. So just keep that in mind. It's not probably going to come into play in Intro to Programming, but if you keep going further in terms of your programming knowledge and you get into real-time applications, there is a trade-off here for efficiency and flexibility. So I have a list demo C# project open here. All I've done is created an empty PartySystem class and an empty character class that we'll use to bring over some of the code from last time and see how to implement a dynamic PartySystem versus the fixed size PartySystem we created last time. So like we did in previous demos, let's pull in the static console class so that we can do lists, demo. Let's print out something. And let's wait for a key to be pressed. And let's also do right line. Press any key to exit. So let's learn about lists, press any key to exit. So we should be good now to start diving into using lists in this application. Like last time, we are going to do some basic practice with lists here, learn the syntax, and then we'll take it to an applied situation where we think about our PartySystem again. So I've got the docs page pulled up here for lists. Lists are a class in C# that live in this namespace, system.collections.generic. So we'll have to keep that in mind when we go to bring lists into our project, that they aren't in the namespace. They aren't brought into our namespace by default. And they have this funky generic syntax, which means that when you create a list, you pass into these angle brackets what type you want that list to be. Generics are a little bit more advanced, so we won't really talk about them in the context of this, but you'll see them often, and they're a really powerful construct in C# programming. If we scroll down, I'll be honest, the first example here is not great for showing someone who's just learning lists, but if we keep going down past that first example, we get to this list where they're creating a list of dinosaurs. This list is a list of strings. It is set to be a new list. And again, here, same kind of structure with the angled brackets here. And here, you're putting the type that you want inside of those angled brackets. Once you've got that list, you can add things to that list. So here, one at a time, a bunch of dinosaurs are added to that list. You can loop over that list using a for loop or a for each loop. Here, they're using a for each loop, print them out. And then you can also do things like down here, remove something from that list whenever you want. Or down here, clear everything from the list. So this page has a lot of good information in it. We'll probably refer to this and look at some of the properties and methods as we go. But let's do something similar. Let's flip back here and let's say that we want to store a list type string, and let's say it is an inventory, and it's a new list, of type string. And you can see that it's going to complain at me that it doesn't know what list is. That couldn't be found anywhere in our project. And if I click on show potential fixes, it's telling me, hey, it's not in your current project, but if you bring in system to collection generic up at the top, you will have access to it. So we could either just do the full path here, system.collections.generic.list to create the list, or we could grab this and just say, let's use it. So bring in generic so that we can just say list instead of the full path. So here's our list. It's empty, but we could still print out how many things are in it. So let's do that. Right line. You currently have some number of items. If this were an array, we would do inventory.length, but it's not an array. And the property that we're looking for is count, which tells you how many elements are in that list. So count will tell you how many items there are. So I'm going to say you have whatever the count is, items. Hit play. We should see 0 print out. So you currently have 0 items. Let's add a note. Array. You use .length, but with lists, you use .count. So our list has nothing in it. If we want to add something to that list, we can simply use the add method of our list and pass in a string. So maybe we're going to add a stick. And we could print out how many things are now in the list. So we should see 0, and then we should see 1. Currently have 0, then you have 1. And if we want, we could add more things. Rusty sword, shiny gem. And we should now have 3 things. So we should go from 0 to 3. So this list is going to resize as we add things to it. And we can also control where we add things. So instead of just doing add, we could say insert. And this allows us to specify the index and then the thing we want to add. So if we want to add something at the top of the list, we could go into index 0 and let's add in a pot of gold. Right now, we're just going to see that there are 4 items, but if we go ahead and loop over this inventory and print them out, we should be able to see that the pot of gold is added before the sticks. So loops, we can use whatever loop structure we want. Let's start with a for loop. So same way that we've done this for arrays, we'll start at I is 0 and go until I is less than the count. So with our arrays, we did .length. Here we're doing .count. We add 1 to our index each time, and then we can print out. Let's do template inventory I. So we still use this bracket syntax to access things from the list, or we still can use that bracket syntax here. So we can say right line. Whoops. Current inventory. So we should see this print out, and then each of our items show up as a list. Whoops, there we go. And you can see that when we did our insert at spot 0, the pot of gold showed up at the top of our list. Let's also practice our for each loop here. So instead of doing this version, we can do the same structure where we're going to say we need a local variable that matches the same type as our list, so string item, and then in, and we put our array here, so inventory. And we will write line and print out our local variable item. We can comment out this for loop, and we should have something that is functionally the same. There we go. Same trade-offs to keep in mind that these two structures, this one we have access to the index if we need it. This one we don't have the access to the index immediately, but we could, for instance, if we wanted to track the index ourselves manually, like this. But usually if I'm reaching for a loop and I need to know the item and its index, I will just go for a for loop. Let's flip back to our docs here and look at some of the methods. So we saw add, we can add something to a list. Clear will remove all the items from the list. Where is it? Contains will tell us whether something is in a list. So it will give us back a Boolean when we pass it in an item. It's going to go through and compare to try and find, is that thing in the list? And just caveat again that this will work for our strings and our ints, and you'll want to do something different when you get into more complex examples of searching. You can kind of compare, you can dig into this example, which uses a custom way to check whether things are equal. Let's just do it. We'll take advantage of the fact that we're using strings here and that it's really easy for us to check if something's in the list. That way we can say is stick, or let's do is pot of gold in the list. Inventory dot contains pot of gold. And if I match the capitalization and spacing exactly here, we should see true. So is pot of gold in the list? True. If we look back at our list, there's also a way to sort the list, which again will work well for the default comparer that is in place for strings and for ints. And then when you want to start sorting your more complex things, you'll need to dig in a little bit deeper. But we could sort, we could reverse like we did with our arrays. The thing that I want to show is remove at. So there's a remove, which allows us to remove something by passing in this case, the string that we want to remove. And there's remove at, which allows us to pass in the index and say, like, get rid of this thing that's at this location. So if we remove at, we pass in an index, this is going to get rid of whatever is at the first index in our array or in our list. So we've got, we added stick, rusty sword, gem, and then inserted this at the beginning. So that means that when this runs, we should no longer have pot of gold in there. And let's put this here. So this will now be false, and we will no longer see pot of gold printing out in our loop. Pot of gold, false, it's no longer there. And if we did that again, it's now, that first thing is gone, pot of gold is gone. If we run this again, it's now going to remove stick because that is now what is there in index 0. So we just have our rusty sword and shiny gem left. So we could say this removes pot of gold and then this removed. So this is great, adding items like this, removing items like this, but the real power that comes in here is that the user's input can control our list. So we could say, let's write line, what item would you like to add to your inventory? And read in the response. And we'll do our trim to just remove any white space around that response. And then we can add that to our inventory. So now we add our stick, rusty sword, gem, pot of gold. We remove our pot of gold and our stick. And then dynamically, based on whatever the user types in, we will add a item after shiny gem. So maybe we want to add a giant shield. And now we have rusty sword, shiny gem, giant shield. And if you think back to our shop, this type of thing allows us to kind of repeatedly ask, like, hey, what do you want? And then we add it to a list. So if you were refactoring our shop application, you could have it so that each time they purchase something, we store that thing in their inventory. And then you allow them to buy something else, and they have this dynamically resizing inventory. So that's the basic setup for a list here. The rest of learning about lists is really just diving into the documentation here and pulling in methods as you go. What I want to do to wrap this up is go back to our example from our array practice, where we created this party system that was a fixed size. We said we've got 3 teammates, we're putting them all in an array, and then we're displaying them. Instead of doing this, let's set up a structure where we can ask the user who's in their team and put that into a list dynamically. So what I want to do is just grab our character class here. I'm grabbing character, copying it from our last project, and replacing my character class here. And then let's bring in and to kind of simplify some of the logic, I'm going to remove the color from this. We could add that back in later, but for the purposes of this demo, it'll just be easier if we're dealing with regular strings and integers. So what we're going to do with this character is ask the user, hey, what's this character's name? Actually, let's make it even simpler. Let's just get rid of the type. We'll do character and level. What's this character's name that you want to add to the party? What's the character's level? And then after we construct it, we'll go ahead and display that team back to the player. So our party system, if we compare back to our array demo here, we're still going to need to create a list as a field, and we're going to need to initialize that list to be an empty list. So we're not going to fill it here. And then in our run method, we'll prompt the player like, hey, do you want to add someone to the party? What's their name? What's their level? And then we'll go ahead and display the full team at the end. So I'm going to create the constructor and the run method back in our list here. Let's do public party system. Public void run. And to do make party from input, to do display the party. Let's just print something out here. Right line, party builder. And then back in program, we can just comment out everything that we were doing here to learn about lists, and we can shift over to creating a new instance of our party system, which would run this constructor, and then calling the run method that we made public. So down here at the bottom of program, we can create a new party system, my party, and call my party.run, and then make sure that if we hit play, we get something showing up on our screen. Oh, and I think I commented out the list thing that I wanted, the title. Let's leave the title in place. So similar structure to our array, we're going to create a field here. So this is going to be a list of type character. And we'll call this my team, like we did in the last one. Here we can my team equals new list character. Whoops. One too many R's here. So I'm creating my team field, and then I'm setting it to a new list. This is equivalent to what we did in program here in one line. We're just splitting this up. We're declaring that we have a field, and then we're initializing it to an empty list. So declare we have a field, initialize it, and let's just throw a placeholder in there. We'll say my team.add new character, main player, and we'll make the players level 1. So our team will always have this main player in it, which will give us something to actually display out here. So we can, for each character, in my team, we can display the information about that character. So we should see our main player level 1 show up here. Main player level 1. Looks good. And at this point, if we wanted to add multiple players, we could just copy and paste this and have player 2 and player 3 added, and our structure would be very similar to what we created with our arrays here, where we just filled in our array with 3 characters and then displayed them. The power of lists is because this is dynamic, we can add and remove people from this list on the fly. So instead of just hard coding this and getting 3 players in there, what I want to do is create a loop that allows us to ask the player, hey, do you want to add someone to the party? What's their name? What's their level? And we'll use that to store into the list. So whenever the player, or whenever we have someone play this application, they'll be able to add as many people as they want. So they can play it once and add 3 people. They could play it again and add 10 people. So we're going to get a flexibility here from our lists. So let's print out something like right line. Let's build a party. And we want to create a loop that asks the player if they want to add someone to the party. And if they say yes, then we can go ahead and ask them for their name and level. So this is a situation where we could use a for loop, a while loop, or a do while loop. But since we have something that we always want to happen at least once, I think a do while would be a good fit for what we're doing here. So we're going to create a string add response variable. And then we will say, write, do you want to add someone to your party? And we'll say the answers are yes, no. our response will be set equal to reading in what the player types, and we will trim and we will convert this to lowercase so that then we can say if the add response is yes in lowercase, we'll go ahead and do our add logic. And we'll finish up our loop here. We want to say that this should continue to run as long as add response is yes. So we'll ask them yes or no. If they said yes, we'll do some additional logic, which means that down here when we check our loop, they've said yes, so we can prompt them again. But as soon as they say no, this logic doesn't run and we're out of our loop. So we should be able to test this. So if I say yes, it's going to keep letting me add people. And then as soon as I say no, it'll print out whoever's in the team. So let's get rid of player 2 and 3. Just leave the main player in there. We'll get the name of the player. And we also are going to need their level. So we're going to have to prompt them before each of these. So let's do a write. What is the character's name? And then we can read line. And we'll do a trim to just remove any white space if they accidentally press space a bunch of times. Whoops, not to trim. We just want to trim. What is the character's level? And remember that readLine is always going to give us back a string. So if we need an integer, we have to actually do a explicit conversion. So here we can take whatever is read in and just convert it to an integer in line. And let's add a little warning. This could cause an error. Remember that if someone types in something that's not a number, convert to int32 throws an error, or if they throw in something that's too big to fit into an integer 32, a 32-bit integer, this will throw an error. I don't want to handle that for this. I just want to like get something simple working, and then we can always come back and fix errors later or catch errors later using try catch. So we've got the name, the level, so we can just create a character. Passing in the name and level that we get, and then just add it to our team. So we get the name, we get the level, we create a new character, we put it into that list, and then let's just print out something like added. And let's throw a new line before each time this loop runs so that there's a little bit of space. So we should hopefully have something that allows us to add characters dynamically and then print them out down here. And why don't we add some space here and say, okay, here's your team. So yes, I want to add someone, and because I am not creative, I'm just going to use our team from last time, Pikachu. Say 10. Do you want to add someone else? Bulbasaur. Charizard. 40. And then we can say no here, and here's our team that prints out. We got our main player, which is me, plus Pikachu, Bulbasaur, Charizard. And if we wanted, now that we've got this whole system set up, we could remove that main player and let the player choose that first player. We could also extend this to add back in our type if we wanted. And if you want a challenge, you could think about adding in the color. The great thing about this list structure is that this time we ran it, we added 4 people to the party. We could also run it and just add 1 person to the party. Now we just have the main player and Pikachu. So this list can grow and shrink to match whatever our needs are in our application. So if we zoom back out here and think about what we talked about, we've got our arrays, fixed size, fixed type, and our lists, which are fixed type but dynamic size. And we saw that we could create both simple types of lists, like using our primitives, string, int, float, double, and we can also create lists that are composed of our custom classes. So same advantage that we had when we were talking about arrays, and we wanted to store like a character's name and their level and their type and their color all together into one slot in the array. You can do the same thing here with lists. We just have a custom class, and we are using our custom class here as we add things to our list. So with arrays and lists, you should be well equipped to store collections of things inside of your applications.